circumference of the base, which is 2 pi r. The circumference of the base that we see is 2 pi r. And if I cut open this, the circumference itself becomes the length of that. So it'll be like, if I just cut open this particular cylinder, you'll notice that this particular length becomes 2 pi r, and this is height itself. Now, if I find out the area of this part, you'll be 2 pi rh, which is length times width. Now, for any three-dimensional shape, you get like generally curved surface area, or lateral surface area is like, when you talk about the circle and all this stuff. So when you're talking about the curved surface area, the curved surface area is generally for any prism is given by perimeter of cross section, cross section times height. So curved surface area is perimeter of cross section times height. If you see curved surface area of a cylinder, this is for prism. This is for prism only. So for any curved surface area, you just find out the perimeter of cross section and multiply with the height. Now I'll give a simple example. Let us say for a prism, let's say there's a prism of this kind of shape. I'm just showing it to you here. So far you might have done is calculating the surface area using different formulas and all. I mean, in bits and pieces. But what I'm doing is, let's say if we can calculate this like at once, like we don't have to look at the particular, so many rectangles here. Otherwise, if we go on to calculate, we'll have to calculate there are trapeziums, there are multiple rectangles, there are 4 rectangles here, there are 2 trapeziums on the cross section. So if you want to find out, let's say curved surface area here. Now curved surface area, when I say, it will cover this part, the side rectangle and the base rectangle. So if you got a prism, the sideways or whatever the paper or covering is required, we call it as curved surface area. And then these two, the front ones, I'm talking about, these are the cross-sectional areas. So now first here, if I take, let's say this length is L1, L2, L3, L4, and this is height h. Height of the prism, let's say, is h. Now, when I want to find out the surface area, when I want to calculate the total surface area or curved surface area, I'm just first calculating the curved surface area. So curved surface area, as I said, is for any prism, only prism, is perimeter of cross section. So if I look at perimeter of cross section here, it will be L1 plus L2 plus L3 plus L4 times the height. So times the height is the perimeter of cross section times height. Now, if you look at L1 times H, now if I open the bracket, it will be L1 times L, L2 times H, L3 times H, L4 times H. So what we get is, in short, all the particular like surfaces which are lateral. L1 times H will be the base area. L1 times H, you can see the base rectangle. L2 times H will be this rectangle sideways. L3 times H will be this rectangle. L4 times H will be the other one. So whenever you're calculating the surface area of any prism, now a lot of students have trouble with this, so that they're not able to visualize how does it happen. Now, if you open the box or this part out here, you will get like a sheet like this with the shape L1, let's say L2, L3, and L4. And if I add them up, it will be L1 plus L2 plus L3. And of course, the height of the sheet is H. And so if you multiply them, you get the entire curved surface area. I still haven't talked about total surface area. Remember that I'm just talking about the curved surface area of any prism. Now, I'm going to give some more examples, which can also further clarify what I'm trying to talk. Is, let us say, if I have, this is one of the favorite questions in GCSE. Suppose there is a piece of cake. This is a piece of cake that we have taken from a big one. Here, this is the cross section. This is the top view where you can see a lot of chocolate pouring. And this angle that you see, let's say this 30 degrees. And what I'm asked to do is, I'm asked to calculate, let's say, for this prism, I'm asked to calculate, let's say, the total surface area or like lateral surface area. Now here radius is given, let's say this is 5, this is let's say this height of the cake or thickness of the cake is, let's say, 10. And I wanted to find out what's the area and, like, so total surface area of this, at least 5 points question. Now in this question also, if you see, it is pretty simple to understand that this is one of the prism. This is also one of the prism. This is one of the shape of the prism. I can just draw it better and I can show it that this is like a proper prism. And we can apply the same formula still. So here if I take this particular length, let's say this is, if I join it with this top length, so you can see that this is like a prism with the same cross-section area. So from top to bottom, the cross-section is same, so it's a prism. Now when I have to calculate the volume of this part, the biggest challenge the student faces is that how do I get this particular length? So this length is actually, if you see, it's like arc length of a sector. And you can just multiply with this height to get this part. But I don't want to waste so much time. So what I do is I calculate the perimeter of cross-section. So I calculate perimeter of cross-section as, first I calculate this length because that's the most important part here. So length will be 30 upon 360 times 2 pi r. I'm not going to do all the calculations here. So I'm just leaving up to you to calculate the exact values. So this is the length of the arc, which we have got. And now for perimeter of, now the formula for curved surface area of a particular like prism is, curved surface area is perimeter of cross section times height. So perimeter of cross section is still not this because we just got this length. Now perimeter of cross section is inclusive of these 2 radiuses as well. So I'm just going to do one thing is I'm going to find out and add these 2. So 2 radius means 5 plus 5. So this will be my perimeter of the entire cross section. Now this value, if I multiply with the height, so this will give me the total curved surface area. And now that will cover, if you see these 2 vertical rectangles, this one and the other side rectangle. But this is still not the total surface area. Now to get the total surface area of any prism, only these formulae that I'm talking about is only for prism. Total surface area for any prism is perimeter of cross section times height plus 2 times cross section area. Because you see, this part was uncovered. We didn't touch base on that because we just calculated according to this formula. We are just calculating the sideways lateral, surface, curved surface area. The cross section area is still remaining. So whenever we're talking for any prism, let it be cylinder, let it be any trapezoid or any particular shape of prism, you always use this formula. So perimeter of cross section times height plus 2 times cross section area. This is the formula for the total surface area of the cone, a total surface area of any prism. So now let us say the first shape that we revisited was the cylinder. Now when you talk about the cylinder, this was the cylinder we started with. We found that the curved surface area was perimeter of cross section, which was 2 pi r times height. So that covered only this curved part. Still, we are not done with this. So we did this part, but we still have to add 2 times cross section because this area and this area, assuming this is a solid cylinder, so it'll be 2 pi r squared. So this will be the total surface area of any particular cylinder. So this, if you want to straight away apply, what is the formula for total surface area of a cylinder? 2 pi rh plus 2 pi r squared. Now sometimes it is open can. In that case, you just add only pi r squared. So these are all common base questions. Now what I'm going to take next is I'm going to take some problems to demonstrate this skill so that you can be more confident. So let us say if I have a cylinder and assuming the different condition, this is the solid cylinder. This is, let's say, hollow cylinder, but there is a covering towards the end. There is lid at the end, and then there is a hollow cylinder. So it's just like an open pipe, and I wanted to find out what's the total surface area or the material that can be used to form these cylinders. Now here, assuming that the radius is 5 and height is basically 10, I wanted to find out what's the volume, I mean the total surface area of this particular cylinder. Now starting with, I'll just straight away start with it's a prism. So you look at perimeter of cross section times height plus cross section area. I'm just going to write it so that you remember it. So perimeter of cross section is 2 pi r, which is 5, plus cross section area into height. So 2 pi r we got, times height will be 10 into 10. This is actually 2 pi rh, if you see, 2 pi rh plus cross section areas. So there are both the cross section areas we got to add. So plus 2 pi r square. So it'll be 2 pi and times radius, which is pi square. So this will be the total surface area of this particular cylinder. Now, assuming that this is open from one end. Now, in that case, you will have this curved surface area, and then this will be the radius. The only one base. So you'll have 2 pi, radius is 5 times height, which is 10, plus pi r square. So you'll take only pi times pi square. While in the third case, it is just the only curved surface area. There is no lids at the end. So it's going to be only 2 pi, radius is 5, and height is 10. So this will be the decoding of the formula for total surface area of a particular prism. So we've got three shapes. First one, we call it as a triangular prism because it's like one mark of question, like naming the prism, triangular prism. And second one, it can be it's a trapezium, like it's a cross-section area trapezium. So we call it as trapezoid. What we have to do is with the given conditions, with the given situation, we have to find out what's the total surface area of each of the prisms, considering they are the solid prisms. So the first thing is that, like, I'm going to just rewrite the formula. That is the formula for total surface area is perimeter of cross section times height. So perimeter of cross section times height will give me, this will give me the curved surface area, you can say, plus 2 times cross section area. For any prism, if it is a solid prism, you can apply this formula blindly. Now, the first one which we look at, the first triangle that we look at is basically, if you see here, triangular prism, the cross section is a triangle here. So the cross section is a triangle in this case. So what you're finding out is like when you're finding out the total surface area here. So it will be, I need to find out the perimeter of cross section. So cross section, I don't know this particular length. So you can apply Pythagoras, which will be 3 square plus 4 square, the root of this, which will be 5. So this length is 5. So we can find out the perimeter of cross section. So what you do is you find out the perimeter of cross section. So it'll be 4 plus 5 plus 3. That's the perimeter of cross section times height, which is 20, and plus 2 times cross section area. So 2 times cross section area is half base times height. Base is 3 and height is 4. So this is the area of cross section times 2. So area of cross section times 2 plus perimeter of cross section times height. So perimeter of cross section is this times height. Actually, now I would just like to show it what's happening. So if I do 4 times, if I open this up, 4 times 20. So 4 times 20 is actually this particular, the standing triangle area, standing rectangle area. Then plus 5 times 20. So 5 times 20 is this lateral, this particular area. And then third one is 3 times 20. So 3 times 20 will be the base area. So 3 times 20 is the base area. So you don't need to do it separately. If we just remember that perimeter of cross section times height, it already gives me all the wrapping around that curved surface area. So this is the, if you calculate this, this will be the total surface area of this particular prism. Coming to the second one, what we have is, in this question, we have 8, 10, but we don't have the height given here. So I'm going to just, let's say, take the height as maybe 5. And I wanted to find out, let's say, the total surface area of this prism. So assuming that's a regular, like, trapezium here. So this, if this is 8, this is also 8. So this and this is going to be 1 and 1. So this length is 1, this length is going to be 1 because the total length is 10. Now what I'm going to do is I'm going to find this length because I need this length for calculating the perimeter. So if you calculate this length will be root of 26 by Pythagoras theorem. So is this length, which is root 26. So now coming to the total surface area of this prism, what we get is perimeter of cross section. So it will be root 26 plus root 26 plus 8 plus 10. That will be the perimeter. So root 26, 8, that is this length, and 10, that is this length from here to here. Multiply by, so perimeter of cross section multiply by height, which is 30, plus 2 times cross section area. So 2 times cross section area, when you look at it, is a trapezium, which is half sum of parallel sides. So sum of parallel sides is, let's say 8 plus 10, which is, and times height, which is 5. So half sum of parallel sides. So I'm finding this area. So 2 times cross section area. So half sum of parallel sides times height. So this will be the total surface area of this particular trapezoid. So the last question is, this is like a wedge that has been removed from a cylindrical shape, let's say original shape. Now, what I have to find out is I have to find out the volume of this particular wedge. I mean, the surface area of this particular wedge. So let's say this height is, let's say 5 centimeters. This has been given, the radius is 10 centimeter, and we have been given that this angle is 30. So I'm just going to do the same thing. I'm going to find out perimeter of cross section times height plus 2 times cross section area. So perimeter is basically theta upon 360 times 2 pi r plus 2 times radius, because that's going to be the cross section perimeter. So 30 upon 360 times 2 pi times radius is 10 plus 2 times radius is again 10 times height, which is 5. So perimeter of cross section times height plus 2 times cross section area. So cross section area is a sector. So sector area is theta upon 360 times pi times radius square. So this is going to be the total surface area of this particular block. And you can do this calculation on calculator and get the exact value.